Hi, math students. It's Mr. Rich here. I'm your math coach for all high school math, from algebra to calculus, ACT, SAT math, and everything in between. Today, in our video, I wanted to go over a few SAT problems involving circles. And I got these problems from Strategic Test Prep. They have a free SAT practice book out, and I thought a couple of these problems would be of interest to you if you're prepping for the SAT. And this first one here gives us an equation that's not in standard form. It tells us that in the XY plane, this graph is a circle, and they want the length of the circle's radius. Well, there is a way to do this algebraically, of course, but I'm also going to show you how to do this in Desmos. Now, if you were to do this with algebra, what you would have to be doing is something called completing the square. And they already have the constant over on the right-hand side. So what I have to do here is I need to complete the square for both the X and the Y variable. So the way that you do that, to complete the square for the X's, is you do take the middle coefficient here of 5, and you're going to divide that by 2, and then you're going to square it, which gives you 25/4. So what you would do is you would be placing a 25/4 right here, but on the right-hand side of the equation, you would have to be adding also 25/4. When you complete the square for the y variable, you have a negative 7y, so you need to take half of that and square it, and that's going to give you a positive 49/4. And therefore, you add that over to the right-hand side as well. Well, what happens here, I'm not really worried about writing the left-hand side in standard form, because this question is just simply about the circle's radius. So the radius is going to be the square root of whatever this sum is on this side. Now over here in Desmos, I think I'm going to have Desmos go ahead and add these fractions together for me, just so that I don't make any math errors. So I'm going to do that. And let me share my screen, because I don't think you can see my screen at this point. Okay, there we go. So yeah, so let me go back over this, since I don't think I was showing you my screen. But what I have here is here was the equation up here at the top. So I took this x squared plus 5x and divided the 5 by 2 and squared it, got the 25/4. Took the negative 7, divided it by 2, and squared it and got 49/4. So now over here on the right-hand side, I have the original 251/2, but I did have to add the 25/4 and 49/4. And I'm doing that over here in Desmos. And you can see that that answer is 144. Therefore, that's the r squared. And so therefore, r has to be the square root of that, which is going to be 12. So again, just to recap here, what we were doing is recognizing that when we put an equation for a circle into its standard form, which looks like this number over here is going to be the square of the radius. And so in order for us in this problem to figure out what the radius is, we had to do the procedures that would convert the x and the y variable into their perfect squares. That resulted in these two numbers being added on the left, and then I would have to add those over on the right side as well to balance it out. Now, if they wanted the center of the circle, well, I would just write the factored form of these two trinomials, right? This would be x plus 5/2 all squared. This one would be y minus 7/2 squared equals 144. But my answer, of course, is 12 for the radius. Now I'm going to go down and do, and I did want to show you one other thing that we can do here. I want to just go ahead and graph the circle, right? Desmos doesn't need a circle's equation to be in a certain form for it to graph it. We just need to go ahead and put the equation in as it is. And Desmos knows how to graph it. So I'm going to go ahead and put this in. There's the circle. Now we want to know what the radius is. So what I can do is try to find where the center is going to be. Now, as I move things around here, right, it kind of looks like it's showing me this bottom part here. And therefore, I kind of know what that center is going to be. So what I'm going to do, I can see that that's an x of negative 2.5. So I'm going to make a vertical line at x equals negative 2.5. And I'm assuming then that that is going to be, since it's showing me this dot on the top and bottom, that's going to be the exact diameter right there. So what I'm going to do is I am going to take that y value and watch, I'm going to hit this little icon right here. I think I need to move myself maybe over to this side. There you go. So you can see this. So what I'm going to do is I'm going to take this point right here and blow it down here so I have that number. Coming over here, I'm going to also blow that point here. And then what I'm going to do is I'm going to subtract the 9.06776 minus the negative 2.06776. And I'm looking to see, since those are the two y values, I should get, see, my radius is 12. Did I make sure I put this in there right? Let's see. Oh yeah, this is the problem, 251. There we go. Now then, okay, this makes more sense. So if you look up here, this y coordinate is 15.5, and now it's negative 8.5. So that distance is 24 units, right? From 15.5 down to this point is negative 8.5. So that's 24. That's the diameter. Cut it in half, you get r equals 12. So my point here is that if you weren't sure how to solve this algebraically, you could then graph the circle and then come up with a way of finding the diameter. And it does default to show you kind of the top and bottom edges of the circle. And then you could subtract the y values, get that distance, cut it in half. That is your radius. Let me show you the second problem that I wanted to work on. And it is the following. It says that a circle in the xy plane has a center at 2, -3 and a radius of 7. An equation of the circle is this, where a, b, and c are constants. What is the value of c? Well, I am going to do a regression on this. What I mean by that is I'm going to come up with 3 points that I know are going to be on this circle because they told me the center and they told me the radius. Now, how would I come up with those 3 points? If I draw a sketch of what they're telling me, that the center is over here at 2, -3, and I know that the radius is going to be 7, they tell us. That means I can go 7 units in either direction. So if I come over here, that's going to be one edge of the circle, and that's going to be 9, -3. I can come 7 units to the left at -5. So that would put me at -5, -3. And I can go 7 units above. That would put me up here at a y value of 4. And so that point is 2, 4. So the circle is basically this way. Now for regression, I need to have at least 3 points. And as you know, the center is not one of the points that's on the circle, right? The function doesn't pass through the center, obviously. So I need these 3 points. And what I'm going to do is insert a table. All right. And those 3 points I'm going to put in. One of the points was an x of 9 and -3. I'm hitting the tab on my keyboard as I move from space to space is usually the easiest way to do this. So I got 9, -3 there. I'm going to put in -5, -3. And then I'll put in 2, 4 right there. So you can see those are the outer edges of 3 points on the circle. Now, yeah, so that's what I want to do there. Now, normally what I tell my students is to use this regression button right here. If you want to find an equation of a line that's going to pass through the points that you've put in your table, that right there is usually the way to go. But if you take a look here, a circle regression is not one of the options for us. But it doesn't mean we can't do our own custom regression using the tilde. So let me, and it even says learn how, but I'm going to show you how to do this. So what I'm going to do down here is I'm going to put this equation in exactly as it is. But one thing to keep in mind, I'm not going to use x. I need to use x1. So when I hit x in the number 1, it knows to make it as a subscript. So I have x1 squared plus y1 squared plus ax plus by. It knows that those are missing constants, plus c. Now, it says equals 0, but when we're doing a custom regression, we have to use the tilde symbol, the tilde, the squiggle, the single squiggle. And that's going to be on your keyboard, usually in the upper left-hand corner, right under the escape key on mine. And I hit the shift and that button. Make sure I'm down here in Desmos. And let me move myself out of the way. There we go. So there we go. So this is what I was working on right here. So there's my table of values. I took those off of the circle. I tried looking here, no circle regression. So I'm kind of ignoring this. So let's get rid of that. Anyway, so here is what I'm typing in down here as the equation that I wanted to fit through my 3 points. So there's plus c. So now what I have to do is I have to use a tilde. And the tilde is going to be, as I said, in the upper left-hand corner of your keyboard under the escape key, and then I put a 0. Now notice I need to put x1. It doesn't recognize anything because I didn't put the y, x1, y1. So there it goes. So what it did is it's going to take those 3 points and find the coefficients a, b, and c that will cause a curve to go directly through those points using this equation. And it gives me the values. It wanted to know the value of c. I'm looking at it. My answer here is negative 36. See that? So you can do your own custom regression. Now, usually when I'm training students on the SAT, I'm just simply directing them to the regression button that they added here a few months ago. But even though their list of regressions doesn't have the exact format that they want you to do, well, you can still do it. You just got to remember to use x1, y1, whatever you have up here as your variables in your table. You've got to use the subscripts for those in your equation. And instead of an equal sign, you have to put the tilde there. If you don't put the tilde and put an equal, it's not going to know that you want it to do a regression. All right. So really super simple. Now, could we have done this without Desmos? Sure, of course. I mean, all of these could be done without Desmos, or they wouldn't be asking you the question to do. So let me move myself totally out of the way here. Let's go down here. So what I'm going to do here maybe is try to show you how I would have done this. What I would have done here is I would have done the following. I would have made the equation in standard form. Since the center is at 2, -3, that's what the left-hand side is going to look like, because this is my h and k that are going into the standard form. If the radius is 7, then I have a 49. And then what I'm going to do is go ahead and expand these out. So this is going to be x squared minus 4x plus 4. When I expand that binomial, it's going to be y squared plus 6y plus 9. And so here's a 4 and a 9, which combines to be 13. I notice I need a 0 over here, so I bring that 49 over, and I have a negative 49 equals 0. Now, I do have the x squared minus 4x, the y squared plus 6y over here still, but what they wanted me to find was the number over here. So I'm not really worried about what those are. I'm just looking right here, and you can see that is a negative 36, 13 minus 49. That's my answer. So really, if you understand how to do this problem algebraically, I would say the optimal way of doing it is going to be what I just did there. If you can square a binomial very quickly, then it doesn't take but about 30 seconds to go ahead and combine those two terms and bring that constant over to create the 0, and then you know what C is. Okay, so two options there, algebra, Desmos, take your pick. All right, so if this video helped you out, hit the subscribe button here and tap the notification bell, because I do math videos every week and I go live multiple times during the week. So I look forward to seeing you back on another video. Thanks, everybody.